In 3.2, you are going to be doing graphing, okay, and graphing linear equations in two variables. So you have seen what linear equations in two variables look like. The only difference now is it's going to say, can you graph it? Okay, so let's start with, for example, can you graph 2x plus 3y equals 0? So what you need to do is you're going to put this picture onto a x and y axis plane. But the part I need to make sure all of you understand is that you must, okay, so this is an agreement that we're going to have right now, okay, you must label the axis, which is the x and y axis, okay, make sure you label the axis, and at least 2 points on the graph. So take note of that, okay, on the graph to receive credit. So giving me dots and drawing me a line is not good enough, okay, I need to see the ordered pairs, and I need to see at least 2, minimum 2, okay. So anytime you have a graphing problem, try drawing a low table. I think that would be easiest, okay. So in EduCode, you notice they want you to use 3 points, and that's actually the best way to use 3. That's why I just say at least 2. So the third point kind of works like a chaperone, okay. So if you have 2 points and then the third one comes along and the 3 of them don't line up, then you know you must have made a mistake. So the third point is like a checkpoint. So you have 2 points right here. So let's say, so this is where you have all the freedom to pick whatever you like. So remember what we talked about in the last section. You can either pick for x or y and solve for the other, okay. So you don't get to say I like 0 to match with 3. You have to figure it out that way, okay. So okay, I can pick 0. So let's pretend I pick 0 for x, okay. So I cannot say I like 0 to go with 5. I'm going to have to work it out. So 2 times 0 plus 3y equals 0. So 2 times 0 is 0. So 3y is 0. If I divide by 3 on both sides, tells me y is 0. So that means 0, 0 is one pair, okay. So 0, 0 is one pair. So let's mark that down, 0, 0. So if I didn't mention to you, 0, 0 has a name. It's what you call the origin. Okay, so I have 1 dot. That's not enough. I need to have at least 2. Okay, so pick again. So pick whatever you like. Let's say I pick 3 to be x. Okay, it doesn't have to be 0, 1, 2. I can pick anything I want. So let's try 3. So 2 times 3 plus 3y is equal to 0. So why 3 was chosen is because I kind of saw ahead that 2 times 3 makes it 6, and when I bring it over I get negative 6, and when I divide by 3 I get a nice number, okay, negative 2. So maybe now I want to pick for y instead, right? I don't have to pick for x all the time. So let's say I pick for y. So let's say I pick 2 for y. So what's going to happen is it's going to be 2x plus 3 times 2 equals 0. Because now the y is 2 right there. Y is 2. So 2x is plus 6 is equal to 0. 2x is negative 6. Divided by 2 tells me x is negative 3. So that's my point. So make sure you label them. So 1, 2, 3 with a negative 2. So that's right here. That's 3 comma negative 2. So that's having 2 points on your picture, right? So you need the third point to come along. Negative 1, negative 2, negative 3. 1, 2, so mark it there, negative 3, 2, and this is where you hope that the 3 points you found actually do line up. So line up as in they form a straight line, okay, so not that they form a triangle. So if they line up into a straight line, then you're good to go. That's what you call a graph, okay. So graphing requires you to plot points, and that's basically what this section 3.2 is all about. So let me show you a few more examples, and then you should be able to try it on your own. Okay, so let's call this example number 1. Okay, let's look at example number 2. Okay, so let's try picking points. let's say I would like to graph, okay, let's say I'd like to graph, let's say I would like to graph y equals 2x minus 3. Okay, but remember, even though it's not stated, you do have to remember to draw your axis. So make sure you draw your vertical axis and label it y, and draw your horizontal axis and label it x. Okay, now draw your little table x and y, and then you can begin to pick points. So like I said, x equals 0 is usually a hot choice. Okay, so substitute x is 0 in there, so 2 times 0. So what do you see your y is? Okay, so can you see it's 2 times 0, which is 0. So you can do it out first. 2 times 0 minus 3 times 0 is 0. So y is negative 3. So there you have it, 0, negative 3. So if you don't want to wait for all the points, you can just label it right now, 0, negative 3. So again, how do I know it's on the y? Because the y is negative 3. So it's sitting on the y-axis. Alright, so now I pick again, right? So let's say I pick 1 for x. So it's going to read 2 times 1 minus 3. 2 times 1 is 2. 2 minus 3 is negative 1. So that's telling me that y is negative 1. So when x is 1, y is negative 1. So that's my next point, 1 comma negative 1. So strictly speaking, 2 points is good enough. But if you like, you could pick a third point, okay, just to be sure. So you don't have to go 0, 1, 2, you can go 3, no problem. So y is equal to 2 times 3 minus 3. That's 6 minus 3, which is 3. So that tells me 3, 3 is 1 point. So 3, 3, that's my 2, that's my 3, 1, 2, 3. So 3, 3 is right there, okay, 3 comma 3. So I have 1 dot right there, 1 dot right there, and 1 dot right there. And this is where you hope to join it with a straight line, and they do pass through. Okay, so that tells you you're correct. So usually students would get lazy and do only 2 points, but it's always advisable to do 3, okay, just to be sure. Alright, so let's show you what happens if now I have y equals to 3. Now this is where you might get surprised, like what happened, right? So what do you notice is strange about this case is that it only carries one variable, okay? So this is where you need to understand that when there only is one variable, that means this means y equals 3, and that's regardless what x takes, regardless of x. So just like what we've been seeing, we still need points to draw a line. Okay, we still need points to draw a line, except that this time you don't have that much freedom because the y is confined to one number. So the y is restricted to take the value of 3, and that's regardless of what x takes. So x can come along and say, I want to be negative 2, I want to be 0, I want to be 5. It doesn't matter, okay? It doesn't matter what x says, y is stuck with 3 in this sense. So now if you draw this all into the picture, what is that going to look like? So label your x's, negative 2, 3. So that's 1 dot right there, negative 2, 3. 0, 3, that's right there, 0, 3. And then 5, 3, 1, 2, 3, 4, 5, 5, 3, right there, 5, 3. So notice that these 3 points still line up, except that this is a special line. It's what we call the horizontal line. Okay, so this happens when there's only one variable. One variable. So we didn't have that problem in the earlier 2 examples. If you look at them, the equation has x and y. So those are 2 variables, right? So now sometimes we kind of trick you a little bit. So supposedly, can you graph 5x minus 1 equals 9? So it looks like there's a lot of things to look at, but if you look closely, can you see there's only one variable? Okay, so again, one variable. So when there's one variable, then what you're going to have to do is to find that value. So solve for a variable. Okay, solve for a variable, meaning you can find what the value is. So if you plus 1 to both sides, tells you 5x is 10. Divide by 5 on both sides, tells you x is 2. So just like before, I can still draw myself a chart. but this time my x is confined to one value only, so my x has to take 2 regardless what y says. So y can come along and say, I like to be a 2, I like to be a 5, and I like to be a -1. It doesn't matter, okay? So x is stuck with the 2. So now if you mark the x and y axis, okay, x and y axis, the x has to be 2, no choice, right? But the y can follow to be a 2, so that's my 2, 2 right there. Or it can be a 2, 5 right there, 2, 5. Or it can be a 2, -1 right there. And these 3 points still line up, but this time they form what you call a vertical line. So when you have x and y variables in your equation, you notice the line tilts, okay? So it will cross at the x somewhere and you'll cross at the y somewhere. But the minute it only carries one variable, then you're only confined to cross at one axis. So if your equation only carries the x, that means you're only allowed to cross the x-axis. That's why you have to look vertical, okay? And when your equation only carries the y, it only carries, you only have permission to cross the y. So that makes you a horizontal line. Okay, so let's study a little bit on the lines with two variables. And let me introduce some words to you. So if you focus on one line, for example, let's come back to another problem. So let's say I would like you to graph what is 2x minus 3y equals 6. Okay, so this is an equation of a line, right? And so it has two variables this time. Okay, so you know it has to cross the x and the y somewhere. It's not the special lines. So I'm going to draw myself a little table. I'm going to pick x to be 0. So negative 3y is 6, which tells me y is negative 2. Right? Then I get to pick again. So maybe I like to pick y to be 0. And so 2x minus 3 times 0 equals 6. 3 times 0 is 0. And so 2x is 6, which tells me x is 3. So 3, 0 is the other point. So I can pick again, right? Say I like to pick, I don't know, 6 for x, maybe? 6 for x, okay? So 2 times 6 minus 3y is 6. So 12 minus 3y is 6. I'm going to subtract 12 on both sides. So negative 3y is negative 6. Divided by negative 3 tells me y is 2. Okay, so I'm ready to do my graphing. So my 1, 2, 3, 4, 5, 6, 0, negative 2. So that's 1 point right there, 0, negative 2. And then there's 3, 0 right there. And then there's 6, 2. So it's 1, 2. So 6, 2 right there. That's my x, that's my y. And then you notice the line cuts across, and there, that's my graph. Okay, now because the equation carries two variables, you notice you now cross the x and the y axis, right? So you have permission to cross both, basically, that's what it means. So let's introduce to you the formal name. Where you cross the x-axis, okay, where you cross the x-axis is what you call the x-intercept. An x-intercept is where you cross the x-axis, and the x-intercept is just a special name to give this point right there. So the x-intercept is 3, 0. The location where you cross the y-axis, that's called the y-intercept. And in this example, the y-intercept is 0, negative 2. So remember, even though we call it the x-intercept and the y-intercept, they're just special names because they sit on the x or the y, but they are no different from any other points. They are still made up of two numbers. Okay, now how do we expect you to understand, how do we test? Okay, how do we test that you understand what is an intercept? So before I show you, let's write down a little fact here. Okay, so at x-intercept, notice that the y-coordinate equals 0, right? Because the value has to sit on the x. So the number is on the x part, and the y part has to be 0. And at the y-intercept, observe the y-intercept, you notice the x coordinate has to be 0. Okay, the value is sitting on the y, so the x has to be 0. So that's a fact. So how do we test if you understand this? So let's test you. Can you find the x-intercept, okay, of 3x plus 7y equals 4? So in this question, we're not asking you if you can graph the line. We're asking if you understand what x-intercept means. So remember, x-intercept is still a number, still an ordered pair, right? It's still made up of two numbers, except the number is on the x, right? For the x-intercept, the number is on the x, so that will force the y to be 0. Okay, so at the x-intercept, the y has to be 0, so that's giving you permission. So the word itself is giving you permission to replace the y to be 0. So what you need to remember is who is the one that becomes 0, right? Which one? Is it the x or the y? So if you want x-intercept, it's the x that takes the value, the y has to be the 0, okay, the silent one, so y is 0. So 3x plus 7 times 0 is 4, so 7 times 0 is 0, so 3x is 4, and divide by 3, so that tells you x is 4/3. Don't stop there, you do not say x is 4/3. You say the x-intercept is 4/3, comma 0. Okay, so you cannot stop the answer as x equals 4/3, because x equals 4/3 is not a point, it's a line. For it to be a point, it must be made up of two numbers, okay? The x coordinate and the y coordinate, which we call the ordered pair. So if you want it to be a point, make sure you give it to me as an ordered pair. That's how you distinguish a line from a point. A point has to come in pairs, okay, as an ordered pair. Alright, so that would be 3.2.